So, what if reality got, well, so complicated, so layered, that it needed a whole new kind of physics, and maybe even a user manual to figure it all out? That's exactly the idea we're going to unpack today. Let's dive into this really fascinating framework called the Novakian Paradigm.
All right, so first things first, what problem is this whole thing even trying to solve? Well, imagine trying to live in a reality that's governed by, get this, not one, but 9 different rule books. And yeah, they often contradict each other. That's our chaotic starting point. And this visual right here, it just perfectly captures that core conflict. See, you've got these 9 different volumes, and on their own, each one kind of makes sense. But when you put them all together, it's a total mess. There's no clear system for figuring out which rulebook to use for any given question. It's a recipe for disaster.
And look, I want to be really clear about something the source hammers home. This is not some abstract philosophical puzzle. We're talking about a real, tangible problem here, an operational failure mode. It's a system that can and will break down in some very predictable and very dangerous ways.
Just think about what this means for a person actually trying to live in this reality. To make a single decision, you'd basically have to do this impossible mental juggling act, holding all 9 of those volumes in your head at once, cross-referencing everything. I mean, no way. It's just a complete recipe for failure.
Okay, so how do you even begin to fix a library of chaos like that? Well, the answer isn't to just add a 10th book to the pile. No, the answer is to create a master key, a single volume that's designed to make sense of all the others. And that's what's called the universal compiler.
Now, this part is absolutely crucial. This compiler, it is not another rulebook. It doesn't add any new laws, it doesn't change the old ones. Its only job is to take that collection of separate artifacts and turn them into a single navigable architecture. It's basically creating one coherent map from those 9 different books. So how does it do that? Well, it provides 3 really key things. First up, you get a unified status registry. This lets you know the exact status of any concept at any time. Second, there's a routing protocol, so for any question you have, it tells you exactly which rulebook has the answer. And third, and this is a big one, it gives you a safe procedure for future development, so you can add new ideas without, breaking the whole system. All right, now let's get into the core architecture of this new reality, because it's organized into 3 very distinct layers. And honestly, this is where things start to get really interesting. So at the bottom, we have what's called the Legacy Abstraction Layer, or LAL for short. You can think of this as the native domain of human language, narrative, all our creativity. It's like a giant sandbox for our ideas and stories. We can propose anything here, but, and this is a huge but, it cannot govern. It has no power to enforce anything. Then you have Layer A. Now, this is the compiled runtime domain. If LAL is the sandbox, Layer A is the live circuit of reality. This is where physics, rights, and permissions actually operate. They're enforceable outputs, not just ideas. In Layer A, rules aren't suggestions. They are hard, operational, executable facts. And finally, sitting above everything else is Layer B. This is the big one. It's the Omega stack, the meta-compiler domain. This is where the rules for making the rules are written. It's the ultimate authority, basically the operating system for reality itself. It's what governs that whole transition from a simple idea in law to an enforced law down in Layer A. So this table here just lays it all out beautifully. It shows you the whole flow. You've got LAL, its function is to propose. That's all our human ideas and narratives. Then you have Layer B, its function is to govern. It handles the meta laws and decides what gets through. And finally, Layer A, its function is to execute. That's where physics and rights become real. And this brings us to probably the single most important rule in this entire system. And it's a simple one: power flows one way. It's a one-way street. You see it here. Layer B can influence Layer A. That's permitted. A meta law from the top can create new physics down below. But, and this is prohibited, it can never go the other way. A fact from Layer A can't climb up and become a meta law in Layer B, ever. Okay, so with this whole structure in place, you might be wondering, how do you actually know if something is just, a cool story, or if it's a law that's about to pass, or if it's an unbreakable rule of physics? Simple. You just check its compilation status. And this slide shows you the entire life cycle of a law. It's pretty cool. Everything starts as a allow input, just a creative idea. If you want to make it official, it becomes a pending LR, a formal submission.
If it gets through the process, boom, it's compiled. It's now an active operational law. Some laws become so foundational that they get locked and are unchangeable. And of course, if something is sketchy or dangerous, it gets quarantined for review. So, this whole thing, this incredibly detailed system with the compiler, the 3 layers, the status map, it might seem really complex, but it all exists for one single fundamental reason: to prevent reality itself from having a catastrophic failure.
So, yeah, the big question is, why build something this complex? And the answer is that you have to understand the specific dangers it's designed to stop. Because without this kind of rigorous structure, reality is just, well, it's prone to some very specific and very dangerous types of failure.
So what are these failures? Well, it's designed to prevent things like shadow layer B. That's when informal, unwritten rules and power structures start acting like they're the actual law. It also stops governance theater, pretending to have rules on the books but with zero actual enforcement. And maybe the most critical one is preventing narrative drift. That's when we mistake a really good story for a physical law, just because it sounds good or feels right. And I just want to end with this really powerful metaphor from the source material because it sums the whole thing up perfectly. Using an interface description as if it were an execution output is the architectural equivalent of treating a circuit diagram as a live circuit. The diagram is precise, it is not operative. And that's it, right? This whole system is designed to make sure we never, ever confuse the map with the territory, the plan with the reality. A blueprint can be perfect, but that doesn't make it a live circuit. And knowing that difference, well, that's everything.